Section 7.4 is showing triangles are similar using the side-side-side similarity theorem and the side-angle-side similarity theorem. So side-side-side similarity theorem says that if the corresponding sides of two triangles are proportional, then the triangles are similar. Remember, by definition of similar triangles, the corresponding angles are congruent and the corresponding side lengths are proportional. So if side AB to side FG is equal to side AC over FH is equal to side BC over GH, if all of those corresponding ratios are equal, then we can say that the two triangles are similar. So what we're going to do is we're going to compare the shortest sides, the longest sides, and then the remaining sides, and we're going to make sure that all of those ratios are equal. So we're going to compare, it doesn't matter, just pick. We're going to compare the sides in triangle A to triangle B, and you want to keep that consistent all three times. You could do B over A, it does not matter. So the shortest side in triangle A, out of the side lengths of 8, 10, and 12, the shortest one is 8. And the shortest side length in triangle B out of 4, 5, and 6 is 4. So 8 divided by 4 is really 2, so that simplifies to 2 over 1. The longest side in triangle A is 12, and the longest side in triangle B is 6, and 12 divided by 6 is 2, so that simplifies to 2 over 1. So far, the ratios are equal, but we need to check the remaining sides as well. So 10 in triangle A over 5 in triangle B. 10 divided by 5 is 2, so that simplifies to 2 over 1. So because my three ratios are equal, 2 over 1 equals 2 over 1, which equals 2 over 1, we can conclude that these two triangles are similar. So let's write a similarity statement then. I'm going to name the first one triangle PQR, use the tilde for similar, and then the second triangle we'll name STU. So I matched up corresponding parts. I started with the short side, and then the remaining side, and then the long side. So PQR is similar to triangle STU. Oh, we wrote the similarity statement on the other slide. So there we go. So write the scale factor of figure B to A. Since it says figure B to A, it does matter which one you put on the top. Figure B to figure A. So that goes on top, that goes on bottom. So we want B over A. It doesn't matter which pair of corresponding sides you pick because as we saw here, they're all going to end up being the same ratio. So let's pick a side in triangle B. It doesn't matter. Let's just pick 4. And 4 corresponds to 8 in triangle A. And 4 over 8 simplifies to 1/2. So 1/2 is my scale factor. So determine whether these triangles are similar. Let's compare all of the corresponding side lengths and make sure the ratios are equal. If they're not, then they're not similar. So the shortest side in, it doesn't matter, let's do triangle JKL in the top, and then let's do triangle RST in the bottom. So the shortest side in this triangle is 5, and the shortest side in the bigger triangle is 9. That does not simplify, so now let's compare the longest sides. 13 is the longest side in this triangle, and 15 is the longest side in this triangle. That does not simplify either. So already we know that those two ratios are not equal, so we can stop there. I will write this just to show you. 12 over 12, okay, that doesn't equal either of our ratios. So we know that 5/9 does not equal 13 15ths, and that does not equal 1. Therefore, my triangles are not similar. Because the corresponding side lengths are not proportional. So first, let's see, is triangle ABC similar to triangle GHG? So let's compare the shortest sides. So the shortest side in triangle ABC is 6, and the shortest side in triangle GHJ is also 6. So that simplifies to 1. The longest side in triangle ABC is 12, and the longest side in triangle GHJ is 14. That does not simplify to 1. We could take a 2 out of top and bottom to get 6 over 7, but those are not equal, so we can really stop there. I will finish just to show you. 9 over 10, yep, so none of those ratios are equal. 1 over 1 does not equal 6 over 7, and that does not equal 9 over 10. Therefore, our triangles are not similar because the corresponding side lengths are not proportional. But now let's see, is triangle ABC similar to triangle DEF? So shortest side in triangle ABC is 6. So let's compare that to the shortest side in triangle DEF, which is 4. 6 to 4. Let's take a 2 out of top and bottom. That reduces to 3 halves. Longest side in triangle ABC is 12. Let's compare that to the longest side in triangle DEF, which is 8. We can take a 4 out of top and bottom to reduce that to 3 halves. So far, the corresponding, the ratios of the corresponding side lengths are proportional. But we got to check the remaining sides. 9 in triangle ABC compares to 6 in triangle DEF. We can take a 3 out of top and bottom, and that gives us 3 halves. So, yeah, 3 halves equals 3 halves, which equals 3 halves. So all of my ratios are equal, so that means the corresponding side lengths, that means all of the corresponding side lengths are proportional. And so therefore, we can conclude that triangle ABC is similar to triangle DEF. Okay, let's do this example. So let's compare the longest sides. Let's go triangle ABC over triangle, figure 1 to 2. They already labeled them. Okay, so let's go figure 1 over figure 2. So the longest side in my first triangle is 18, and that compares to the longest side in triangle 2, which is 12. So we can take a 6 out of both of those, and that simplifies to 3 halves. Shortest sides are 12 and 8. So 12 in figure 1 over 8 in figure 2. We can take a 4 out of both of those, and that simplifies to 3 halves. And then remaining sides, 15 compares to 10. We can take a 5 out of both of those, and that simplifies to 3 halves. So yeah, 3 halves equals 3 halves equals 3 halves. Therefore, my triangles are similar. So let's write a similarity statement. Let's call the first figure triangle ABC, and let's call the second one, let's see, if we went A, B, C, then we have to go D, F, E. So that does not end up being alphabetical order. So we went green side, blue side, red side, so we got to do green side, blue side, red side again. Scale factor figure 1 to 2. So this is important. The order does matter. So figure 1 is going to be in the top, figure 2 is going to be in the bottom. So let's pick any side. It doesn't matter which one, because all the ratios are going to be equal, since we just proved that they were similar, and we showed that all the ratios of the corresponding side lengths were congruent, were equal. So let's pick figure 1. Maybe let's just pick 12. Corresponds to 8 in figure 2. If we take a 4 out of both of those, we get 3 over 2 for our scale factor of figure 1 to figure 2. Now let's talk about side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides that include these angles are proportional, then the triangles are similar. So the angle in between those two sides has to be congruent. And then the two corresponding side lengths have to be proportional, just like we just did for SSS. So here's the included angle. Remember, it's the angle that the two sides make up. So as long as those angles are congruent and the sides are proportional, then by SAS, similarity theorem, we can prove that the triangles are similar. So let's compare. Are my angles congruent? Yes, angle C is congruent to angle F because they are both 61 degrees. So they're congruent because they're the same measure. So we can say angle C is congruent to angle F. Let's compare the longest sides. The longest side in triangle ABC is 6, and the longest side over here is 10. So let's divide both of those by 2, and we get 3/5. And then let's compare the shortest sides. Now, since we put triangle ABC in the top over here, we have to put, and then we put triangle DEF in the bottom. We have to do the same thing for the shorter side. So we have to do 3 in the top, which compares to 5 in the other triangle. So yeah, 3/5 and 3/5. Since those are equal, by SAS, we can conclude that these two triangles are similar. So I like to write it like this: SAS, this side was 3/2, this side was 3/2, and this angle measure, they were both 61 degrees. So we can now conclude that triangle ABC is similar to triangle. So let's see, we did ABC, so over here we go DEF. Just make sure your corresponding parts match up. So we already wrote the similarity statement on the previous slide. So now we want to show that these two triangles are similar. Now, I'm going to rewrite these two triangles. First, we have triangle VWX. So we have VWX. This side is 4 and this side is 5. And then we have the bigger triangle, which is VYZ. So we have VYZ. So here's the hard part. How long is this side? It's 8 plus 4, which is 12. And how long is this side, VZ? That's 5 plus 10, which is 15. So you got to be careful there. And now we want to show that they're similar. Okay, well, angle V overlaps with angle V. It's in both triangles. So we know that angle V is congruent to angle V because it's the same angle in both triangles. And it is the included angle between the two side lengths that were given. So let's check if those side lengths are proportional. So let's compare. All right, here we go. These are split up for us. So again, we already said that angle V is congruent to angle V. And then let's compare the shorter sides. So the shorter side over here is 12, and the shorter side over here is 4. Well, 12 divided by 4 is 3. So this simplifies to 3/1. And then let's compare the longer sides. 15 in this triangle compares to 5 in this triangle. Notice that I did triangle VYZ in the top both times. VYZ and then VWX. And 15 divided by 5 is also 3. So this simplifies to 3/1. So yeah, my included angle is congruent, and the corresponding side lengths are proportional. So therefore, we can conclude that triangle VYZ is similar to triangle VWZ. So just be careful when you split them up. Just make sure you get the full side length here and here. And that is section 7.4.